For today's question, what we're going to do is to answer an algebra challenge coming from one of our followers. And the question goes like this. Find real values of x that satisfies this equation x raised to the power of square root of 2 equals 1 minus ln x. Pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. Given this equation x raised to the power of square root of 2 equals 1 minus ln x, we only have one solution in this kind of question. Oh, here's the reason. Because x raised to the power of 2 is strictly increasing, so this function is strictly increasing, while 1 minus ln x strictly decreasing. So when you have a function strictly increasing on one side and on the other side strictly decreasing, so there's only one intersection. Therefore, we only have one value of x that satisfies this equation. So now, here's the solution. To answer this, we need to let a equals ln x. Now, if we do this, we can say that x equals e raised to the power of a. So we can replace this x with e raised to the power of a, and this ln x be equal to a like this. Now, we can simplify this. The left-hand side of our equation, we can multiply the exponent. So this is just e raised to the power of a times square root of 2 equals 1 minus a. Now, at this point, what we're going to do is to use what we call a special function, and its name is the Lambert-W function. Now, if we have an equation n times e raised to the power of n equals m, wherein n and m are all real numbers, then if we take the Lambert-W function on both sides, the left-hand side of our equation, this is simply equivalent to just n and must be equal to Lambert-W function of m. So if we have this kind of pattern and we take the Lambert-W function, we get the exponent of e, or the number before e. So by the way, this is called the Lambert-W function, and we will apply this to our equation. But before that, take note that we have here a times square root of 2. So our first step is to multiply both sides by square root of 2. Now here's the reason, because we have here a times square root of 2. Now we have a times square root of 2 on the right hand side of our equation. But this is negative and this exponent is positive. So what we're going to do is to divide both sides by e raised to the power of a times square root of 2. Because, take note, when we simplify this, or if we take the reciprocal of this expression, we have a negative exponent. So we can rewrite this as e raised to the power of negative a times square root of 2. Now, we have now negative a times square root of 2. But the only problem is we have here square root of 2. In this exponent, we don't have square root of 2. So what we're going to do is to multiply both sides by e raised to the power of square root of 2. That is the trick for this kind of question. Now, we have the same base, so we can add the exponent. So the exponent of e now becomes square root of 2 minus a times square root of 2. Now, as you can see, we have here e raised to the power of square root of 2 minus a times square root of 2. And we also have square root of 2 minus a times square root of 2. Now, on the right-hand side, if you look at the right-hand side, we only have the same pattern, square root of 2 times e raised to the power of square root of 2. Now, if we take the Lambert-W function on both sides, what we're going to do here, the left-hand side is just equivalent to square root of 2, and the right-hand side is equivalent to just square root of 2 minus a times square root of 2. Now, we can now solve for the value of a. So if we subtract square root of 2 on both sides, we have 0 equals negative a times square root of 2. Divide both sides by negative square root of 2, we get that a equals 0. But take note, we don't care to the value of a. We care to the value of x. Now we know x equals e raised to the power of a. Now this a, we can replace this with 0. And e raised to the power of 0, any number raised to the power of 0, must be equal to 1. Therefore, x equals 1. This is the only value for x that satisfies this equation. And of course, here's the checking. So as you can see, we have 1 equals 1 on the left-hand side and the right-hand side of our equation. Therefore, given this equation, x raised to the power of square root of 2 equals 1, minus ln x, then the only possible values of x that satisfies this equation is x equals 1. And as always, we are done.